Welcome back to our course, Networks and Distributed Systems, based on the textbook by Jim Caros and Keith Ross, Computer Networking, a Top-Down Approach. We've been talking about the network layer, and most recently we have studied BGP 4, Border Gate Protocol 4. We will conclude our discussion of Border Gate Protocol starting now. As described earlier, BGP uses eBGP and iBGP to distribute routes to all the routers within the autonomous system. From this distribution, a router may learn about more than one route to any one prefix, in which case the router must select one of the possible routes. The input to this route selection process is a set of all routes that have been learned and accepted by the router. If there are two or more routes to the same prefix, then BGP sequentially invokes the following elimination rules until one route remains. Routes are assigned a local preference value as one of their attributes. The local preference of a route could have been set by the router, or it could have been learned by another router in the same autonomous system. This is a policy decision that is left up to the network administrator. The routes with the highest local preference values are selected. From the remaining routes, the route with the shortest autonomous system path is selected. If this rule were the only rule for route selection, then BGP would be using a distance vector algorithm for path determination, where the distance metric uses the number of autonomous system hops rather than the number of router hops. For the remaining routes, the route with the closest next hop router is selected. Here, closest means the router for which the cost of the least cost path, determined by the intra-autonomous system algorithm, is the smallest. If you'll recall, this process is called hot potato routing. Why different intra and inter-autonomous systems routing? Three big issues: policy, scale, and performance. Local administrators want control over how traffic is routed and who routes through their networks. As far as scale is concerned, hierarchical routing saves table size and reduces a lot of traffic. And performance is an issue, and with intra-autonomous systems, the local administrator can focus on performance. Well, there are a number of other issues pertaining to the network layer, such as broadcast routing algorithms and multicast routing algorithms. But I believe that we have covered the nuts and bolts of the network layer. And I believe this is a good place for us to put an end to it, prepare to move on to the next layer, that being the link layer of the TCP/IP model. So, go back over your notes, go back over your videos, review the material that you've learned, update your study guides, and come on back when we're ready to start the link layer.